Welcome back. So we got the base of a solid is the region enclosed by an ellipse. Don't disappoint Miss Kerslake. 4x squared plus y squared equals 1. If all plane cross sections are perpendicular to the x-axis, yep, this means we are integrating with respect to x, are semicircles. Formula happens to be pi r squared, but divided in 2 since it's only half a circle. And we want to find its volume. Well, the very first thing I better figure out what the region is that I'm stacking all of these semicircles on happen to be. So we've got 4x squared plus y squared equals 1. Since I'm perpendicular to the x-axis, that means I'm going to be integrating with respect to x, which means I'm going to solve for y. Y squared equals 1 minus 4x squared. Y equals, again, the square root, that plus or minus, which gets me 1 minus 4x squared. So we have a calculator, so we can easily put this into my graphing calculator so I can see what it looks like. There's going to be the top of my ellipse. If I want the other half of my ellipse, I've got to put the other half of the equation into the graphing calculator. No, there is no other way. And I graph, and we can see it. Now, if you're not sure where those points are, I think we should be able to look at the table. Nope, see lots of errors and everything else. Nope, everything's in errors only because we're counting by whole numbers. But that's okay. It's easy for us to figure out. It looks like a half. Let's verify that it's a half. So those are our zeros are a function. We know zeros occur when y is equal to 0. So if I make y equal to 0, I get 4x squared is equal to 1. X squared equals 1/4. So my zeros of that function are plus or minus 1/2. So we've gone there, there, and so we do have this elliptical figure. Again, we are perpendicular to the x-axis, so I always like to draw where I would place my Play-Doh there. So my Play-Doh semicircle would go right here, perpendicular to that x-axis. So I'm going to be accumulating those semicircles starting over on the left, and I'm just going to keep working to the right until I get to the other side. So now in my volume, again, since I'm going from this negative 1/2 to 1/2, is going to go from there to there. There's my limits. I'm going to take my formula for the area of the semicircle, and it's pi halves, whatever my radius is squared, but we know we're going to put it in terms of x. The challenge with the semicircles is always figuring out what the radius happens to be in the figure. We know our sides of our squares and equilateral triangles and such are usually constrained by the whole function, top and bottom. But your semicircle, when you place it down, this is the diameter of the semicircle. Therefore, your radius of your semicircle is only one piece of this, from the function to the x-axis. So our radius really only has a length of, by the way, in case we didn't know, this is the square root of 1 minus 4x squared. This one is negative square root of 1 minus 4x squared. Refer to the other video, the previous video, if you needed help on that piece. So our radius in this case happens to be created and restricted by that top curve, that's square root of 1 minus 4x squared, and the bottom curve on this one, which is 0. So your radius will always have the length of 1 minus 4x squared. Now, could I have used the bottom one? Absolutely. I could have found the radius this way. If I don't have to deal with the pesky negative, though, I choose not to do that. So if we can find this piece right here, this makes everything much, much better, because now I'm just going to plug it into my area formula. I'm going to take out that pi over 2 because it's just a constant. Kind of gets it out of my way. Square root of 1 minus 4x squared, all squared. Everything in terms of x. Very nice. Simplify before I integrate, which means if I square that, that gets me 1 minus 4x squared dx. So feel free, Math 9, all of this, a little bit easier, less work that you have to do. Again, I like to make sure I practice my integration skills because I want to make sure that those are good. pi over 2, so my antiderivative would be x minus 4x cubed over 3, all from negative 1/2 to 1/2. Again, if we math 9 that, you're going to find that the answer is 1.047. If you take the time to use a fundamental theorem of calculus and you want your most exact answer, you're going to get pi over 3.